So like we just said, to name a major arc, you need 3 points, but it has to be more than half a circle. So if you pick BEC, that is not a major arc. Okay. What are 3 points on the edge that make more than half a circle? What do y'all think? Okay, B to F to C, that does go more than half a circle, right? That's very major arc. So we're going to write those 3 letters, BFC, but we're going to put a arc on top. Cool? So that's how you notate an arc. Now a minor arc, all I need are 2 points, and it's going to be the shortest distance. What are 2 points on the edge? Okay, so E to C is a short distance. That is a minor arc, so we can put EC, but we got to make sure we put an arc on top. And then last but not least, we learned that a semicircle is half of a circle. Literally from one point of a diameter to the other along the edge. And I need 3 letters, so the diameter I see going through the middle is EF. So if I go along this edge, what would my 3 letters be for this arc, semicircle? ECF is my semicircle arc. Now, we're going to do the notes again. So let me pass this out. Pass these to those 2 guys. After this, sure. One. Here we go. All right, so here's our notes. These are going to be short and sweet. So yesterday we learned about notation and vocab. Today we're talking about specifically tangents in a circle. So check it out. Tangent property number 1. If a line is tangent to a circle. So look at this picture off to the right. Do you see this tangent that touches the circle once right here? And you see the radius from the center to that point of tangency. What kind of angle does that make right there? What do you see? Okay, you see 90 degrees where the radius and the tangent line touch. So what do you call it when 2 lines make a right angle? The P word is they are perpendicular. Perpendicular. So again, tangent line, radius, they are perpendicular. And that's perpendicular to the point of tangency. Point of tangency. Okay, so we're going to apply this down here. Does everyone have this written down in my class? Here we go. Example 1. It says that the radius is 3. So if I know r is 3, wherever I see that little r, I'm going to put 3. So there's actually 2 radii labeled here. This r is 3. This r is also 3. Now here's the deal. Because we just learned that the radius and the tangent segment make a right angle, if I connect them, I get a right triangle. And we're going to have a missing side of a right triangle. Let's remember a few units back. How do I find the missing side in a right triangle if I know 2 sides? Pythagorean theorem. Okay, a squared plus b squared equals c squared. So before I start writing an equation, I'm going to redraw this triangle. I like to see it nice and clean. So here's my right triangle. What was on the left of the right triangle here? The r, which is 3. So label that 3. Now check it out. Across from 90, this hypotenuse has a part of 3 and another part of 6. What's the whole length if it's 3 and 6? Yeah, you add them up and you get 3 plus 6 is 9. Cool. And the one we're missing is this bottom leg. I'm going to call it B. This is a lowercase b. Like I asked earlier, like I said, if you're missing a side in a right triangle with two other sides, you use Pythagorean theorem. Let's write it down. A squared plus b squared equals c squared. Cool. A squared plus b squared equals c squared. Now, which one's A, which one's B, which one's C? So if you remember, A and B are next to the 90, the legs. So this one's A, B is down here, and across from 90 is always C. Cool? Okay, so let's fill this in. A is 3, so I'm going to replace it with 3. So 3 squared plus B is missing, B squared equals C is across from 90, 9 squared. So here's the question. Can you solve this equation from like a few units ago? Pythagorean theorem problem. So I fear that that might be the truth. So here's how you do this. You need to square these numbers. What is 3 squared? Don't say 6. It's 3 times 3, which is 9. So 9 plus b squared. And what is 9 squared? 9 times 9 is 81. Of course, you could also just type it in your calculator, but hopefully you can do some math there. Now, can you solve it from here? If I'm solving for b, how do I get rid of this 9 on the left side? We have to subtract it. We are not combining them because they're not on the same side. So you get rid of that 9 by minus 9, minus 9. Okay, so b squared equals 81 minus 9 is 72. Now, I hope you remember this, but whenever we're trying to get rid of a square, we have to use the opposite. What's the opposite of square? Square root. Okay, so the opposite of squaring is square root. Here's how it looks. Square root, square root. So you are allowed to use your calculator, okay? To do this, you don't have to do simplified radical form. Just give me the decimal. Square root of 72 is 8.485. The 5 will make the 8 round up, so 8.49 units. Could you do that on your own? Okay, so I want you to try example 2. I'll give you like a minute. I want you to try number 2. It's literally the same idea. Label it, redraw it, solve. Once you nail this, you know what I'm saying? Get it, get it, get it. You need slate, right? All right. Here we go. Example 2. Did you label it? If x is 4, did you put a little 4 and a 4, right? So here's a 4. Here's a 4. If I redraw that triangle, okay, B is on top, it's still missing, 4 is over here, and on this whole hypotenuse, 6 plus 4, right, 6, 4, together, we add them up and we get 10. All right, so can you solve this? Once again, it's a right triangle, so here's my A and my B is missing. Across from 90 is my C. So A squared plus B squared equals C squared. A is 4. 4 squared plus B squared equals C is 10 squared. And can you square numbers? 4 squared is 16, not 8. B squared, and then 10 squared is 100. All right, and you get rid of that loner, you get rid of that constant 16 by subtracting 16. b squared equals 84. And then, of course, last step is square root. What is the square root of 84? 9.165. The 5 rounds the 6 up, so 9.17. Okay. If you got that down, you can flip it over to the back side so we can show you one more thing and we'll be done. Okay. All right. On the back, anyone still need this from the front side in my class? Everyone's good on this? All right, on the back, here we go. Property number 2 about tangents. Now look. Look, now, instead of one tangent and a radius making a right triangle, what if we have 2 tangent lines or 2 tangent segments? So if 2 segments are tangent to a circle from the same external point, then the segments are congruent. Write that down. So again, one tangent segment that touches it once, another tangent segment that touches it once. It looks like that picture. If you see that picture, then you know that this segment and this segment are congruent. Segment AB is congruent to segment AC. Put away. Now, what does that mean? Well, when I see this picture, I see those are 2 tangent segments. I'm going to put little tick marks on it. I know this and this are congruent. So all I got to do is set them equal and solve. So let's do that. 5x minus 28 equals 3x. Can you solve this equation? That's the question. When x is on both sides, do I combine them or do I get rid of one? What do y'all think? Anyone at all? What do you think? Do I combine the x's or get rid of one? Combine is not right. Okay, they're on different sides, so I want to get rid of the smaller x, which is 3x. So this will be weird, but let's get rid of 3x. It's positive, so I'm going to subtract 3x. Subtract 3x. On the left side, 5 minus 3 is 2x. Bring down minus 28 equals 3x minus 3x cancels out and gives me 0. It's weird, but it's okay to have 0 for like a second. Okay, but we're going to keep going here. If I'm solving for x, next I got to get rid of this loner minus 28. The opposite of minus 28 is plus 28 on both sides. 0 plus 28 is 28. Bring down that 2x. And now my last step is to get rid of that 2 by dividing. Remember, you divide to get rid of a coefficient. X is 14. 28 divided by 2 is 14. Okay. Do you see how this works? You set the 2 tangent segments equal and you solve. Now that means you should be able to do 4 and 5 on your own, but if you look at number 4, how is 4 a little bit weird? What do you see in the numbers here? See a little square. So for some people that's like, whoa, what do I do? So I'm going to show you how to do it. Once again, example 4, they are tangent segments. Put a tick mark, tick mark. I know they're congruent. I'm going to set them equal. So 2x squared plus 5 equals 13. Can you solve that? Let's try it. If I'm solving for x, before I get rid of anything, I need to get rid of this loner 5. How do I get rid of a plus 5? The opposite is minus 5 here. And you always do it on both sides. Bring down 2x squared equals, what's 13 minus 5? 8. So Now, what do I do next? If I'm trying to get x by itself, do I get rid of the 2 or the squared? And I'm telling you, it's the coefficient 2. Just like last problem, to get rid of a coefficient 2, you have to divide. Divided by 2, divided by 2. Wait, x squared equals 8 divided by 2 is 4. Now, just like with Pythagorean theorem, where are your notes? Just like Pythagorean theorem, my last step, to get rid of a squared, what's the opposite of squared? Square root. What is the square root of 4? What times what is 4? If you're not sure, you can always just type it in, but hopefully you know it's 2 times 2, right? So square root of 4 is 2. That's it. X is 2. Okay. So I think by now you know what to do, but real quick, I'll do number 5. Tangent segments are equal. You set them equal. X is on both sides, so you get rid of the smaller x. Bring down everything else. Get rid of the loner by doing the opposite. And then you get rid of the coefficient by dividing. And you should get 4. Okay, so I'm going to pass out your assignment. Your priority is to finish yesterday's assignment first, and then you can work on this one. You have today and tomorrow to get those done.